So our second lesson is on multiplying matrices, which is quite a bit different than adding, subtracting, I think, because, well, first of all, you can have two different size matrices. We no longer have to have same size matrices. There are some requirements to the sizing in order for this to work, but we have a lot more variability and flexibility. So I've already written up here in the box the multiplying matrices. You should already have that from in class. So if we re-look at that though, we have matrix A here, and we use a dot, so A dot B. We say A times B, matrix A, matrix B, we get this resulting matrix. So here's how it works. We start by saying, in class, what we did was I said, if the way I learned this was if you take your left hand and kind of hold it out in front of you and move your left hand side to side, and at the same time as you move from left to right with your left hand, at the same time you're taking your right hand, and as you move left to right, left hand, you move up to down with your right hand. And so that looks like that. So those arrows represent left hand going side to side, right hand going up and down. And what happens is we take A times E plus B, I'll put two dots, times H. So we take first element times first element, and then we go down one row and across the other column, down one column across the other row. So AE plus BH. We take those numbers, those multiplications, we add those two products together. So A times E plus B times H, and that goes right here. And the reason it goes in that first entry is that in this left column, in this left matrix, we're taking first row times first column. So here we have first row, first column. That gives us this position. Then if you look, we would then go to our next set. We would keep our row the same. We would keep our first row in the left matrix. We would take our second column in the second matrix. So now we still have A and B, but we're taking A and B times F and I. So first element, first column, A times F plus second, so AF plus BI, and that's where we got this from. So it's first row, second column. That's why we get first row, second column is where we would put that. And we would continue this process all the way through. So we keep taking A and B times column 1, and we get the position 1. And then first AB times second column, and that's where we get that AF and BI. Then we take AB times our third column, and we keep going until we have run out of columns in our second matrix. So A times G, that's supposed to say, plus B times K. So AG plus BK. And that's how you get those positions. So let's do an example quick. We happen to have a 2 by 2, so this is gonna work based on our sizing, but I'm gonna say, so first row times first column, so -1 times -3, so -1, -3, plus 0 times 5. And that is our first position, first column, first row. Then we've done first times first, now we go first times second. So in this position we have -1 times 3 plus 0 times 0. Down here in this position we have second row but first column, so 3 times -3, 3 times -3 plus -4 times 0. And then we've done, oh, that's not right. That's my fault, sorry. So 3 times negative 3. I went to the wrong row, or wrong column, sorry. So 3 times negative 3 plus negative 4 times 5. I do apologize for that. Now we go to the second column. So second row, second column is 3 times 3 plus negative 4 times 0. So our matrix is, so let's see, that's 3 plus 0, so 3. It's negative 3 plus 0. It's negative 3. Bottom left entry is negative 9 minus 20, so minus 29. And 3, that's 9 plus 0, so just 9. And that's how you get the multiplication, the product of multiplying those two matrices together. Now, what's going to happen down here, what you'll notice is all I'm doing between this example 1 and example 2, what we're finding is we have switched. So if this is matrix A and this is matrix B, we're saying A times B. Now down here, we're saying, well, that's still matrix B, but we're putting it first. We're going to say B times A. What we will find, in traditional algebra, what we've known algebra to always be, which by the way is actually called linear algebra, we could take 3 times 4 and get 12. We could also switch that and say 4 times 3 and still get 12, and that's always true. A times B is B times A. That's linear algebra. What we are dealing with is matrix algebra. So we're still doing the algebraic product of two matrices, but we get a very different answer. So I'm not going to write all of the math out, but you'll see that, so negative 3, negative 1, that's 3 plus 3 times 3 is 9. And then negative 3 times 0 plus 3 times negative 4. And then 5 times negative 1 plus 0 times 3. And 5 times 0 plus 0 times negative 4. So what we get is a different matrix. Negative 12, 0. So all I did was I switched the order in which I multiplied. But look at between here and here, order matters. Because if all I do is switch the order A, B, B, A, we get two very different products. So I'll write that rule down here. Actually, it's not even a rule. It is finding the dimensions of a product. So let's say I have this matrix here. We say 2. So we have a 2 by 4. We're going to multiply that by, let's go 1, 2, and okay, so we're taking these two matrices. We have a the dimension of this, remember, it's rows by columns, so 2 by 4, and then we have this matrix, rows by columns, that is a 4 by 3 matrix. So a couple things to note about this is if we look at this, we can determine, can I do this matrix? So let's for example, let's really briefly, let's wipe that out. We're going to call that, erase that. We now have a 3 by 3. Okay, what you're going to find is, as I go, first times first, so 1 times 6 plus 2 times 3 plus 3 times 3, all of a sudden we have 4 times, well, there's nothing down here. There's no fourth row here. So as we went 1, 6, and 2, 3, and 3, 3, 4 doesn't have a corresponding entry. So we actually cannot multiply these two matrices. So what I wanted to point out was just that what we'll find is, in order to work, we want to compare the two inside numbers. If the two inside numbers, as I write it out as matrix size for A times matrix size for B, if my two inside numbers match, then we're good to go. If they don't match, doesn't matter what they are, if they do not match each other, you cannot multiply them. You'll find that your entries don't work, they don't line up. Now, if I did this, I would do 1, 6, 2, 3, 3, 3, 4, 2. That all, so that entry goes right here. Oop, I better not use zeros. You'll have an entry here. Then we'll go and we'll keep that first column, second row, so we'll have another entry. We'll go first row, third column, we'll have another entry. And then we'll go first row, and we don't have any more columns, so we're done. So then we're completely done with that first row in our final product. So then we go to our second row. Second row, first column, we get a point. Second row, second column. Second row, third column. We're done. So our resulting matrix is a 2-row by 3 column. And that is always going to be your outside numbers. So if you're being asked, can I multiply these matrices? You look at the two inside numbers. And if your answer is yes, then you would say, it would ask, what dimension would your product matrix be? You would look at the outside numbers and say your resulting product will be a 2 by 3 matrix. So order matters. Remember, order matters not only in the fact that you can do these. So this one here, this is a 2 by 2 matrix times a 2 by 4 matrix. If I look at my inside numbers, I have a 2 by 2, I'm good to go. My resulting is a 2 by 4 matrix because my outside numbers give me that dimension. So inside numbers match, I know I can multiply them. My resulting matrix will be a 2 by 4. If I take R times S. Now look at this. If I take S times R, my S times R, what just happened there? Sorry. My S times R is going to be S's and just 1, 2, 1, 2. So we have a 2 by 4 matrix first times a 2 by 2 matrix. Now all of a sudden I have a 4 and a 2 on the inside. This is an undefined product. So order absolutely matters, not only in, maybe you can multiply them both A times B and B times A because the size matches, but you're still going to get a different resulting matrix. The other thing though is you may find that by switching the order, you just can't even get a defined matrix. So are they both possible? No. The last thing I'm going to do here, I only have about a minute, it says determine if the following product exists. So what you're going to do is you're going to compare inside numbers. I get a 4 by 4, yes. I'll put a star there. It says if so, describe the size. Well, the size is 3 by 5. So 3 by 5. Then we're going to look at the next one, 6 by 3, undefined. My inside numbers don't match. Same thing here, 7 by 4. I'm just going to put ditto marks. The last one, yeah, it does work. Inside is 1 and 1. My dimension is also a 1 by 1 matrix. So there you have it. That is matrix multiplication in a nutshell, under 15 minutes. That's all I got. So good luck, and we'll do another video for our last lesson.